Good day, and welcome to CFE Media's Virtual Training Week. For this session on how to unleash the power of smart manufacturing while ensuring automation and robotic safety, we'll be joined by Ted Rozier, Director of Engineering for the Festo Didactic Solutions Center, North America, with headquarters in Mason, Ohio. I'm Kevin Parker, an editor with CFE Media and Technology. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of this program will be reported to RECEP at recep.net. A certificate of completion will be issued to each participant. As such, it does not include content that may be deemed or construed to be an approval or endorsement by RECEP. Digital manufacturing incorporates smart machines and robotics into smart factory environments that enable integrated systems to support connectivity and traceability while driving production based on cyber-physical infrastructure. To thrive within the Industry 4.0 era, manufacturers, workforce agencies, and educators must identify the key challenges they face by pursuing both the integration of emergent technologies and the personnel upskilling that will streamline future business best practices. To do so, they need answers to at least two questions. What emergent technologies will empower advanced automation and pervasive robotics use? What tangible changes to systems integration best practices encourage adaptable, user-friendly environments that allow advanced systems and human beings to interact on factory floors? 2, what technology best practices should be applied in education and industrial environments to support manufacturers hiring skilled labor talent attuned to emergent technologies and comfortable working in data-rich digital infrastructures? In any given industrial environment, performing risk assessments should be an integral part of forming definitive answers to these questions. Attendees are eligible for 1 PDH credit for this live educational event airing on October 18th, 2022, and is categorized within the health, safety, and welfare, including core technology category or RECEP. You see before you the learning objectives for today's session. Additional resources can be viewed and downloaded on the left side of the screen below the session's agenda. If you would like to take notes within the session, click on the left panel labeled Notes to do so. Please remember that this session will be made live at 10 a.m. Central, 11 a.m. Eastern. Question and answer session with industry experts will start approximately at 10:45 a.m., 11:45 a.m. Eastern, or immediately after the presentation ends. If it runs a little longer than 45 minutes, answers will be archived with the session. You can see the Q&A details in the Meetings tab on the left side of the screen. Zoom invite details can be found in the Additional Resources tab under Q&A session. Want to take the session again? No problem. This session will be available on demand. If you're experiencing difficulties, please log out and back into the session to continue. Attendees are eligible for 1 PDH credit for this event airing on October 18th, 2022, and is categorized within the Technical Health and Safety, including Core Technical Category, or RECEP. This event is a live educational session presented on October 18th, 2022, and on demand afterward. I'd now like to introduce today's presenter, Ted Rozier, Director of Engineering for Festo Didactic Solutions Center North America, with headquarters in Mason, Ohio. Before joining Festo Didactic, Rozier brings 20 years of experience in leading the Automation Engineering Department for Doosan Infracore Machine Tool Corp. He specialized in the design and development of robotics and machine tool turnkey systems for the automotive, aerospace, and pharmaceutical industries. He has managed the development of several user-friendly automation control turnkey systems on a global scale. As Director of Engineering of Festo Didactic, Rozier is passionately looking to advance Festo Didactic as a global leader in designing and implementing Industry 4.0 learning factories and demystifying 4.0 career paths with a view to systematically prepare individuals to excel working in dynamic and complex industrial automation environments. TED's volunteering efforts have included with the Advanced Robotic Manufacturing Technology Advisory Committee, the Robotics Industrials Association Robotics Safety Committee, the Association for Manufacturing Technology Technical Service Committee, and the Ohio Manufacturing Association Chief Technology Advisor for Robotics and Automation. So without further ado, I would now like to introduce Ted Rozier. Ted, welcome to today's virtual training week session, and please go ahead.
Ladies and gentlemen, my name is Ted Rozier. I am the Director of Engineering at Festo Didactic North America. I will be handling the presentation entitled, Are You Ready to Unleash the Power of Smart Manufacturing while Ensuring Automation and Robotic Safety? When we think about Industry 4.0, the era of 4.0 is most definitely upon us today. Industrial manufacturing companies as well as educators are facing strong demands to increase their productivity and training capabilities by implementing Industry 4.0 methods into their factories and educational training programs. Within this discussion, we will focus on tangible solutions that will assist individuals in transitioning a plant environment of legacy equipment into efficient, smart factories by focusing on three key elements: MES integration and productivity, job roles and how they will be affected by Industry 4.0, and the power of a risk assessment strategy. Now, while we're all excited about Industry 4.0 technology advancements, but we must also clearly understand that Industry 4.0 involves people, how we think, how we react to problems. It also lends itself to one of the biggest challenges, employability of the workforce. So before we get into our discussion, let's just make sure that we have a clear understanding of our topics and what we will take away. We'll first talk a little bit about who we are, Festo Didactic. Second, we'll get into what is a connected worker. Third, true cyber physical systems is what we will dive into. We'll talk about the career pathways, job roles, robotic risk assessment, and then for the cherry on top, we'll do a little bit on case studies, just so you have a clear understanding of what robotic risk assessments look like when we tie it all into smart manufacturing and the system approach. So who are we? When you think about Festo automation overall, on the left-hand side of the screen, it clearly shows that when it comes to factory automation, process automation, valves, cylinders, sensors, electric drives, that would be what 20,000 employees globally, those would be the things that Festo has done for several of years. On the right-hand side, you'll see that we also have an educational sector, technical education, where training and consulting, learning systems are designed and developed. And that's who I represent as the Director of Engineering. So it's Festo Didactic. Now, when it comes to Industry 4.0, this is something that we are very motivated towards, the demystification of Industry 4.0. And today we're going to focus on that. So before we dive into I 4.0, let's allow a video to inspire us on the connected worker.
Ready to manufacture the individualized product base, Peter 2018.
Okay, let's go. But let's make the stand first.
Starting cutting process. Okay.
Okay, thanks.
While watching the video, I'm sure that you all noticed a few technology tools that are considered to be new to the manufacturing floor of the future. You may have noticed an autonomous mobile robot. You may have noticed the collaborative robot, which we like to say collaborative automation versus collaborative robot, but we'll talk about that a little bit later. And then you may have also noticed the 3D vision system. When it comes to the power of connectivity, it's all about the control architecture as well as the term of interoperability. It's the special sauce in the background that connects all this technology together so that the human being can work very nicely along with it. Now, Industry 4.0 has a lot of buzzwords to it. And in our discussion today, the goal is that we demystify a lot of these buzzwords. When we think about some of the buzzwords on the monitor here, I'm sure you can see digital twin, augmented reality, generative design, simulation, cybersecurity, big data and analytics. I can't tell you how much we hear about big data and analytics, but without the demystification. But what we want to do with Industry 4.0 is kind of make sure that we're all on the same page. So let's kind of go on that journey together. So when we think about 4.0, of course, we have to get there. So we start with 1.0. The first industrial revolution moved society from manual to mechanical by harnessing steam and water power and replacing raw muscle and strenuous craftsmanship. This marked the end of the 18th century. So the overarching terminology of this phase would be called Industry 1.0, mechanization. Now, moving on to 2.0, the second industrial revolution took advantage of electricity and the assembly line to generate mass production. This marked the start of the 20th century. The overarching terminology for this phase would be called Industry 2.0, electrification. The third industrial revolution took off using electronic and software. So the most iconic example of these two coming together would be the computer and the programmable logical controller, the infamous PLC, in the industrial atmosphere. This gave rise to an era of high-level automation. It marked the start of the 1970s, and again, that overarching terminology of this phase would be called Industry 3.0, automation. Now, one of the things that I like to do when we talk about Industry 3.0 is make it very clear that 3.0 and 4.0 are different, of course. I like to call Industry 3.0 automation a la carte because it's not about the overall system approach and several pieces of equipment being able to talk to each other. It's about the island of automation. Okay, so when we move on to Industry 4.0, Notice that here, the fourth industrial revolution is happening right now. And according to research, the physical world and the digital world and the virtual world are colliding together, creating smart products, procedures, and processes, which make smart factories. The study goes on to describe this revolution being brought on primarily by cyber physical systems and the Internet of Things to create a highly intelligent, integrated, and automated manufacturing ecosystem that spans far beyond the traditional factory floor. So that overarching terminology, Industry 4.0. So I would like for you to keep the cyber physical systems in the forefront of your mind as we move forward. Let's erase the buzzwords and let's keep Industry 4.0 cyber physical systems on the fore of our minds. So what is cyber physical systems? Well, you can see here cyber physical systems, the integration of physical processes, computation, and networking, collecting and harnessing a tremendous amount of data to make better decisions. In the end, collectively, the data should tell business leaders in all disciplines, from the top floor to the shop floor, what to do and when to do it. And that's where that interoperability comes in. So cyber physical systems should tell you what to do and when to do it. There has to be a true connectivity from the equipment to visualization and to the human being. Now, when we talk about a cyber physical system, what happens is we definitely have to keep in mind something that is very powerful here in the automation pyramid. So when we talk about automation pyramid, it's what we would call, some call it the automation stack. And notice the different levels. The field level and the control level would be the shop floor. Now you have the supervisory level, that would be the HMI, human machine interface. But then the heart of Industry 4.0, we like to say, is MES, the planning level. And then, of course, at the top is ERP. Now, years ago, when we thought about ERP and supervisory level, so the supervisory level and the management level, what's set in between there? Well, there was a bunch of meetings and paper. But MES allows the human being to interact with the system. So we can see here that with the automation pyramid, how many levels do you have? Field level, control level, supervisory level, planning level, management level. So there's 5 levels, whereas in the past, there were only 4. So as we look at the automation stack, the one thing that we have to understand is that if you are looking to transform your manufacturing plant from brownfield to what we call greenfield, well, we need to unleash the power of the control architecture. That means you would ask yourself the question, do I have a manufacturing execution system that sits above my robotics, my machine tools, my conveyor systems? Something that is analyzing and having connectivity from a human being down to the automation at all times. That's why you see on the right-hand side that this is where we're shifting to more of a flexible and adaptable control architecture that's connected to a cloud for analytics to be stored there. The data can be correlated there, and everyone should be able to reach it at all times, that data. So when we look at the control architecture, you see that we have some red boxes here. In this image, the red boxes would be things that we've taught for many years. PLC, HMI, that HMI, human machine interface. But the human being is only connected through the HMI that's connected to the PLC. That's not a cyber physical system. A cyber physical system would mean that the things that are in the blue boxes, you see the Ethernet switch is allowing several bytes of data to be connected and going back and forth. You see in the blue box that was just presented, manufacturing execution system there. You see that the human beings are connected there, connected to the complete process and not stuck at the machine. Now, something else that is very important when we talk about Industry 4.0 smart manufacturing would be the Digital Transformation Maturity Index. So we've talked about the hardware and the control architecture up to this point. But the maturity index, there's something to keep in mind. And you hear this a lot. Sometimes we connect Industry 4.0 and digital transformation as the same thing. It's not the case. Digital transformation is when technology, process, organizational culture are aligned to impact business models and correct new revenue streams. So the journey that we're going to go on, now we've talked about what Industry 4.0 is. Now we're going to show digital transformation. And what does that actually look like when we are connecting or collecting information? Well, when discussing the maturity index, I like to split the chart up into 3 phases. So we look at phase 1, and what do we see? Phase 1 is all about 5S and the 2 C's, computerization and connectivity. Now, these two work together. A good example would be a CNC machine. Many years ago, the application engineer would type all G-code data into the control by hand. Would put the work orders and part specifications on a clipboard. But due to CAD/CAM programs and advanced computerization, we now have the ability to develop coding offline, test it for accuracy, store all the data on a network. This allows work orders to be sent to the machinery and also assist in quality tracking issues. So today, even in mom and pop shops, we're seeing that machines are all tied together and networked together, where part program management, quality assurance, and work orders are completely networked together. And that would just be one example. There's several other examples that speak nicely to the 2 C's. Now, stage 1 and 2 are defined as Industry 4.0 preliminary steps. These are preliminary steps as you go on your journey. And I can happily say that a good portion of organizations are at the beginning of the journey. Although there are a lot of manufacturing plants that are not operating in what we call brownfield equipment. That leads us to phase 2. When we look at phase 2, we're looking at what's happening, visualization, and then also transparency. Now, visualization plays a huge role in the process of data collection, as well as the software management piece of the puzzle. When most of us think of visualization, we might think of 3D models that we use to bring HMI alarms to life. But at this stage, companies using sensors for real-time recording of conditions and processes. They produce a digital model of production, a digital shadow or digital twin that shows what's happening at any given point. Now, interconnectivity of sensor data is seeing it in real time as well as the system process data. Once we have true connectivity at the sensor and process level, now we're on our way to phase 3, where we start to see predictive capacity as well as adaptability. Now, when we talk about transparency, understanding what's happening, this is where your journey really starts to get very interesting. Therefore, we're going to take a deep dive here. Now, notice the path that leads to transparency requires the correct communication architecture. This means that we're not only talking about a hardwired cable that turns ones and zeros on, but we need to have what we call a data conduit. The data conduit is where Ethernet connectivity lines, the ability to push and pull data. So what kind of data are we talking about here? Well, we want to interrogate PLC data, data from the edge, visualization, and correlated data from other processes. So we see visibility, transparency. What are we looking for again from the PLC? Well, we're looking for in-feed, out-feed, waste, and the state of the equipment. If we have an MES system, we need to look for availability, quality, and performance. And then from the visualization side of things, we need some specific tools to go on our journey. We need MEF, HMI, and mobile device. Do we have these tools, and are we able to connect with our MES and HMI via a mobile device? Those would be questions that we would be asking if we're going on this journey and we're connected to a true cyber physical system. In the end, our number one goal is to take all the information that we are collecting and make sense out of it. So we don't want dark data. We want information where that we're able to connect it. And when we have interoperability through the data conduit, we can push and pull information that's going to make our manufacturing process rich and lean. In the end, what does it look like? Well, if you look at your control architecture and we bring that to life a bit, this image kind of shows that we want to, at the shop floor, capture. Then we connect. Then we convert, we network, distribute, and consume all the way up to the cloud. That's what that connectivity looks like. So hopefully this image will reside well in your mind, helping you to see what it looks like when we are connected from the top floor to the shop floor. The only thing that's missing is the human being that's capturing this information, consuming it, and making changes to the operation. And we'll talk about that some more as we move forward. Keeping in mind that a true cyber physical system, there is an autonomous response in the end. And that autonomous response, a great example of it might be an AMR, autonomous mobile robot. Years ago, we always said that any repetitive task is being given to a robot. But we're not talking about a repetitive task. That would be going back to Industry 3.0. But 4.0 cyber physical systems means that that robot is collecting information from the top to the bottom, and that when it learns, as it learns of issues that might require adaptability, that it has the ability to do so on its own. That means a round part, a square part, a prismatic part, that through a vision system that robot might say, I have the personality to do something that is not repetitive because it's been empowered by several data points. So when we think about decisions being made by automation, we talked about the heart of Industry 4.0 and cyber physical systems being MES. Let's learn about MES and how MES has the ability to interact with the shop floor. We're going to watch a brief video here, about 5 minutes, so sit back and enjoy. The enormous rise in the quantity of data and the complexity of networking a plant requires developing systems that make the flow of data easy to handle. MES is what we call a manufacturing execution system, and it is the heart of Industry 4.0. This is the layer of controller software that truly connects the top floor, which is your ERP, your Enterprise Resource Planning System, into your actual production shop floor process. The true value of an MES is that you have full interoperability, meaning the shop floor communicates to the top floor. Decisions are made, and that goes back down to the shop floor for the implementation instantaneously. This takes all of your data, smart sensors, your condition monitoring, as well as your customer production orders, and combines that into a system where we can have dashboards and we can see what our cycle times are, what our idle times are, and how much energy we are actually consuming.
It's very important that skilled workers understand intelligent components in order to operate and optimize their facilities. It's also very important that they learn not only the structure, but they also know how to program the digital facility networks.
With the CP Lab, we've implemented MES4, which has all of the same functionality of an industrial MES, but it's built for the classroom, meaning it's easy to implement as an easy user interface, but it still gives you that full interoperability. It still gives you the capability to export data and make decisions, to do data analytics.
With this interface between research, production, and training, Festo Didactic works on providing learning systems and curriculum which students and skilled workers can actually prepare themselves for digital production, and the CP Lab can get you there. So what did we learn? Our Industry 4.0 training solutions come well equipped with all the tools needed for success today and tomorrow. But let's start off with the RFID chip that is embedded inside of each carrier, which allows us to push, pull, and store 128 bytes of data on the chip. Now, at each station, we have what we call a stop gate. The stop gate consists of 4 digital proximity sensors. These recognition sensors allow us to collect binary data in clusters for part type management, as well as an RFID sensor. We also have an air-driven stop gate cylinder, which is basically an actuator that stops the part when it comes in, or the carrier when it comes in, and then allows for us to push and pull that data like we talked about earlier. This means that at every station that the carrier stops at, we have the opportunity to query the MES and ask the part, what's happening? Remember, that has to do with visibility. And then after what's happening, then we have the ability to say, why did it happen? And that's transparency. Let's now see the system in reality. The part will enter the magazine station and put one part on top. We now enter into the pressing station. Once the part is pressed, it moves over to the turnover station. Now keep in mind, at each station, we are pushing and pulling data. The final station would be the labeling station. I'm going to remove the part from the process. Typically what would happen is the part would be packed out. But let's get back to what we're talking about. Here we're talking about traceability. So at the labeling station, what happened? A QR code was placed on to the part type. The information on the QR code comes from where? Our MES platform. So you can see that when we talk about traceability, it takes us back to our maturity index. That second phase clearly defined visibility to transparency. And what sits in between both of those? Traceability. So the MES platform speaks to the RFID, and we push and pull there. And we also get a chance to speak to the label maker and define what on the part. We get a chance to view the QR code, as well as the timestamps, the order number, and the order position. With all of this technology blended tightly together, Festo Didactic is sure that we have the most powerful tools for today and tomorrow. So if we just clarify a few key points that we talked about in our cyber physical lab, is what you saw on display. And that's platform, we really call it a playground for Industry 4.0 methods to be exercised and validated. But in speaking about the MES4 software in helping and how it helps us to overcome shop floor challenges, what are we looking to get from an MES? Real-time machine data collection, edge logic, data transformation and integration, overall equipment efficiency reports and other KPI calculations, database base and IT connectivity and cloud connectivity. Now, when we think about OEE, overall equipment effectiveness, I just want to make sure it's very clear what we're looking at. Overall equipment effectiveness. This was something that was invented in the 1960s. And basically, the founder of the Total Productive Maintenance, TPM system. So OEE is a key performance indicator calculated by manufacturing companies to measure manufacturing processes. So if we think about electricity, an electrician, an electrical engineer, what is the method that they use in order to know that how they design a circuit is correct? Well, they use Ohm's law. When it comes to smart manufacturing, you need a formula, and that formula would be OEE, overall equipment effectiveness. So we think about that formula, and just like Ohm's law, there's a formula. For OEE, it's the availability, performance, and quality. Availability, performance, and quality. Now, up to this point, we've talked a lot about data, the technology side of Industry 4.0, how it aligns with the digital transformation. But Industry 4.0 is not just about data, it's also about people. So the same journey that we went on, we talked about the 6 different points of lean manufacturing, the 2 C's, computerization and connectivity you see at the bottom. Number 3, visibility, transparency, predictability, and adaptability. Well, you see, people have to move right along with technology. Our behavior has to move with it. We have to learn to trust the data. So it's not just about technology taking off, but the training of individuals also must sit side by side with the technology. So let's talk about what that looks like a bit. People on the shop floor and job roles. So when it comes to job roles on the shop floor, the first thing we're going to talk about would be the technology roadmap that an individual would go down, the path from A, B to C. Noticing that the first thing that we're going to look at when it comes to that journey, an introduction to Industry 4.0. So what is Industry 4.0? Just like we went through today. Then you have the fundamentals of mechanical systems, the fundamentals of AC/DC. These are things we've been teaching for years. Fluid power, hydraulics, pneumatics, sensor technology, fundamentals of PLC, the fundamentals of robotics. See, all of these things we've been teaching for many years. And when you look at level 1 there, or A, that bottom row, you would definitely think possibly level 1 or mechatronics. Now, notice that dotted line to a foundational hook course. So while you may be going through mechatronics in all of these topics or competencies a la carte, that hook course of Industry 4.0, the fundamentals, should inspire you to understand how you transition from Industry 3.0 and start to get into 4.0. In the end, what are you looking for? When you see the red circle, You should be stacking up your competencies and capabilities to the point where that data management, traceability, interoperability are tied into your courses, and you understand how these terms play a role in the complete systems approach. Then you have smart maintenance. Well, what does that mean? Smart maintenance is when we're not chasing the red light, but we are anticipating the red light. And then there's cybersecurity. So if you look at the control architecture that we've talked about, that automation pyramid and the adaptability, if you have a true cyber physical system, that red circle and those three topics there will be very important in defining your journey. Are you headed there? And are you exercising competencies to strengthen you to be able to align with these three boxes? Well, what's going to help you do that? Well, it's going to be job roles, Industry 4.0 job roles. So when we talk about these job roles, you might notice that some of these job roles, you might not see it. The HR department might not have them in the as listed as a job, because these are basically overlays. So we have Industry 4.0 production specialists. Second, we have smart maintenance specialists. Third, we have smart process specialists. Last but not least, the role that does a lot of the heavy lifting, system integration specialists. Now, if we focus on the production specialists, what job role is that in the manufacturing plant? Well, in the manufacturing plant, that's the operator. And the goal when it comes to, if the system integrator has designed the system as a cyber physical system, then that production specialist role is going to be very easy because at this job role, the system should be talking to them. Notice what the production specialist does. Operate, monitor, and troubleshoot networked equipment. Smart production specialists make informed decisions based on data and visualization tools. So you may recall we started our discussion watching a video, the connected worker. That would be the production specialist. So as we start to transition and we go on this journey and we start converting manufacturing plants from brownfield to greenfield, individuals are not losing their jobs. The systems are talking to them. Operators are now production specialists. They're making better decisions due to the visualization tools, due to OEE. That's what we talked about, overall equipment efficiency. So OEE should be tightly integrated into the PLC programs. The OEE calculation should be tightly integrated into the edge. The two should come together and help that operator to make great decisions so that when you escalate to the next job role, smart maintenance specialist, well, because the production specialist is making great decisions and listening to the machinery and the data collected, that smart maintenance specialist is now focusing on tomorrow and not looking at problems of today. But you have to have the right control architecture in place, as hopefully that you're able to see here. So what are some additional tools to empower the connected worker, the production specialist? Well, if you recall back to the video, there were several tools that were being used. There was a collaborative robot, which we're going to talk about, or collaborative automation here. But you see that connected worker also has the ability to use a tool called augmented reality. This tool of augmented reality is where we suggest education and industry start their Industry 4.0 journey. If someone were to ask, okay, I'm ready to get my classroom Industry 4.0 ready, I want to start right now. The same for a manufacturing plant. We would always say augmented reality. And why is that? Augmented reality connects the worker. It's almost like we talked about Ethernet cable. Ethernet cable and a Ethernet switch. You plug the two together, and you're able to push and pull bytes of information. Well, if a human being needs information, do we take that Ethernet switch and plug it into the human being? Of course not. You can't do that, but you can use augmented reality. Augmented reality is almost like plugging that Ethernet switch into the human being, because it's going to give that frontline worker, the connected worker, data immediately. Now, some may argue the fact that when you talk about augmented reality, it may be said that, well, now the student doesn't learn all the core competencies to make great decisions. Augmented reality must be designed in such a way where it helps the production specialist or the operator, but it should also send them to the sheet music. The sheet music means that when someone's playing the guitar, the piano, whatever it is, they might hear music by ear and play, but the great artists are able to go back to the sheet music. And if augmented reality can take you right to your electrical, mechanical documentation, now that student is still learning. That incumbent worker is still learning all about manufacturing and the personality of it, but they can do it a lot faster. It's at their fingertips. So the power of connectivity comes through augmented reality. Now we're going to get into the portion that we're talking about robotics. So when you mix the system approach, data management, all together in one, we can easily start to think about the future. And we can get very excited and forget about the risk assessment is where I'm trying to get here. When we talk about the factory of the future, do we need to consider a risk assessment? Absolutely, we do. And one of the ways to consider the risk assessment, we like to take students and incumbent workers on a path of a safety awareness bundle. So Festo works very closely with our partner SICK. And what we have in some educational facilities would be the safety awareness package. You have area scanners, safety PLC, a safety relay that can be attached to any robot, industrial robot, collaborative robot. When you combine this together along with the curriculum that goes along with it, it starts to teach the student what safety, what a risk assessment looks like, okay? So safety has always been taken very seriously at Festo, and Festo follows what we call the V model. The V model gives us structure to make sure that our automated processes, the build of valves and systems, we want to make sure that we always provide a safe machine. So the V model aligns with several of the protocols used for safety. Now, we work very closely with SICK. So we looked at the hardware components, but what does the software look like? Well, if you take the V model and then you take six steps to a safe machine, that would be a risk assessment, safe design, technical protective measures, administrative measures, overall validation of the machine, and deployment of the machinery. Those would be the 6 steps to a safe machine. What Festo and SICK have done together is combine these 2 concepts and providing a strong risk assessment, which is a safety awareness tool. So it trains students on things about risk assessment so that they are never forgotten on their journey into a cyber physical system, into a smart manufacturing space. So how does it work? Well, we start off with the job roles. Here we see who are the users? Is it the robot operator or is it a robotic maintenance technician? Then we go into the task. We look at the normal operations, the stocking and restocking, the load, unload of material. That would be for a robot operator. And what are the differences in their roles? Well, of course, the robotic maintenance technician does periodic maintenance, troubleshooting, problem solving, clearing jams, cleaning machines. So we consider risk assessments per the operator or per the user. We look at what tasks they perform, and then now the student can take those tasks and then look at the risk evaluation tree. So when we talk about a risk evaluation tree, a lot of times you might look at this, you're looking at this screen, and there's a lot going on. It might even put an individual to sleep. But if you walk the student through these processes and help them on their journey, they actually will get pretty excited. Because what we do is we define clearly what are the risks. So here when we talk about risks, this is the risk awareness worksheet. And this is the exact tool that a student would have in hand as they are walking around their system. So you look at the first column, risk. We would look at a sharp end of arm tool. An end of arm tool is something on the end of a robot. Then we would look at high speed robot motion, and then possibly trip hazards. That goes back to what we talked about earlier today in our discussion, the difference in a collaborative robot and collaborative automation. So we're looking at the complete system in this risk awareness worksheet. Then we define what is the severity? What does frequency mean? What does the avoidance mean? What does the performance level mean? And then we come up with a rating. Is it acceptable? So you can see this is that worksheet being worked out, and you can see how nice it is for the student to go on that journey and start to learn the power of a risk assessment. So just so we're clear, the safety awareness bundle would be 2 area scanners. One area scanner takes care of 180 degrees of a system. The other one does 180 degrees, and in the end, you have 360 degrees of protection. They learn how to connect those area scanners to a safety PLC, a safety relay, and then tie it into any robot. Here we have a universal robot control panel, but Festo works with all robot manufacturers. Therefore, this safety awareness kit allows us to be able to kind of put a safety suit jacket around any robot, tie it into any robot, and now they have learned those safety competencies. So when we think about the overall protection, the goal is that an operator can walk very close to a robot as it's working. And there are zones set up, as you can see in the picture here. If the operator is in the yellow zone, the robot slows down. But it not only slows down, there's data that's being captured by the machinery, and that data is being sent up to the top floor so that the system reacts differently. If I know there's a human being close to me, now I can start, that system now starts to react totally differently. It's acting differently because it's a collaborative system. So it knows a human being is there. So maybe the speed of the robot is cut down to 0.5%. And there's another field set or a zone that's where you see the red zone there. Now that robot would now possibly come to a pause, making sure that it does not affect the human being. Again, the data is being captured at all times, being sent back to the operator, being sent back to not only the operator, but the machinery is always aware of the operator. That's a true collaborative automation system. So we talked about collaborative robots, and let me not say collaborative robots. Remember, collaborative automation. Collaborative automation, again, takes our mind back to what we talked about in the beginning. That was where this was the workplace of the connected worker. And there you see the autonomous mobile robot. Festo calls it a Robotino on the left side. Collaborative robot, again, 3D cameras tightly integrated so that the human being works very closely with the automation. A very user-friendly work environment is what the factory of the future looks like. When we look at a safe workplace, just so that we get a good, clear picture, we're looking for any sharp edges to be round edges. And that's part of our risk assessment. We're looking for trip hazards again. That's, again, part of the risk assessment. So collaborative automation is going to be free of pinch points. Yes, the robot is there, but even the end of arm tooling, no sharp edges. All of that is taken into consideration in the design phase so that in the end, you have a very adaptable process. Before we end, we're going to just look at a few case studies. In this application here, this is one of my favorite because what happens is the programming of the robot on the left-hand side is not defined before there is a risk assessment. So on the right-hand side, you have a human being that has gone through every phase of handling the part and part inspection. So this application will be called man versus machine. So the right-hand side, the human being has a vision application for inspection. Behind him, he has some fuses, and he's going to build up a circuit board. Now, after understanding the risk, the human being handling the operation and the amount of time it takes, now we take all of that knowledge along with the risk assessment and we build up the robot on the left side. Notice that robot has guarding around it. But if you consider the risk assessment in the design phase and you're very intimate to the process, you could imagine you could easily take that, remove that guarding, and you could apply what? The safety awareness package. 2 area scanners to make sure that you are covering the module 360 degrees of coverage. And now that robot has the ability to interact with it as well. But the goal here is to show that a true risk assessment can be taken. And in the end, now when you start to program that robot, you're intimate enough with the process where that there's great data, not only from a safety standpoint, but you're also pushing great data from the shop floor to the top floor. All of it was considered in one bundle. That's what we push for. Now, another case study would be the programming and integration of safety when it comes to CNC machines. There is a right way and a wrong way to integrate a machine tool, and especially when we think about risk assessment, it has to be taken into consideration. In this application here, there is also a AMR, autonomous mobile robot, that's integrated up front, in front of the robot training cart. So there's a few things to keep in mind in the risk assessment. How does the AMR interact with bringing parts to the robot cart so that the robot can run lights out? This is a lights out manufacturing scenario, and yes, a risk assessment must be done here. In order for that to happen, there's a lot that gets done in the communication between the AMR, autonomous mobile robot, and the robot system. There's interoperability, Bluetooth connectivity. So what do we mean by that? Well, when the AMR gets close to the robot training cart, it gets into the yellow zone. What happens is now we can send a signal saying that a robot has approached it, so it will mute just one section of the safety awareness package. So there's a small section that has been carved out digitally so that that autonomous robot can get nice and close and remove the finished parts and bring in raw parts. And now that system can continue to run lights out. There's another case of when you do a risk assessment the right way, considering more technology being added, you're going to be able to collect all that data and make sure that you have a safe work environment as well. The last case study would be when we think about a risk assessment, having a robot on a rail. So there's a 7th axis rail here. It's the top view. On the right-hand side, you'll see that there's a CNC machine, and then there's also room for other types of machinery to be integrated. We can bring a laser engraver into this. What you see, there are an orange box, a blue box, a red box, a purple box, and a green box. Those would be field sets. And when we think about the risk assessment, as that robot is moving down the rail, we're keeping track of the encoder. We know the coordinates of the 7th axis, and therefore we set up virtual or digital zones. So as that robot is moving down the slide, it's still safe. It's going to enable these field sets that a human being cannot interact with to make sure that the environment remains safe. So these are tools that are very powerful for the factory of the future. Now, we're not saying that you don't have to have cell guarding integrated into your systems anymore. Sometimes cell guarding is the best thing for the application. But as we move forward into the factory of the future, smart manufacturing, we'd like to get more automation, and that means we need more real estate, and we need to get more robots integrated and where human beings can interact with those robots. That means that some of that cell guarding is going to go away, and then what we do is we integrate the safety awareness package. Those area scanners, and then making sure that we have a safety PLC, making sure that the integration of the system not only slows down, stops the robot, but captures all of the data. We push that information out to the MES, and now you have a well-rounded solution that will stand the test of time. It was really nice talking to you, ladies and gentlemen, today. As we wrap up our discussion, the one thing that I would like you to keep on the forefront of your mind would be, again, this digital transformation journey. So where are we today based upon our discussion? Lean manufacturing and the 2 C's, computerization and connectivity. That's where we are now. And there are several manufacturers that are there. What's next? If you have taken care of the lean manufacturing portion and computerization and connectivity, what's next would be transparency and visibility, phase 2, which we call next. And then beyond, at the top, would be steps 5 and 6, predictive capacity, and then adaptability. Keeping in mind that if there is an MES platform that sits at the top of a true cyber physical system, what are you going to be able to do? That MES platform is going to allow you to push and pull information, and that information that's being sent from the top floor to the shop floor is going to be accurate because we did things the right way, ability to capture the information. But the other thing that we keep in mind is risk assessment. If we do all of this together, keep that risk assessment along with the engineering up front, we're going to have a true smart manufacturing operation. That means our classroom is going to be smart, as well as the manufacturing floor being smart.
Well, great, Ted. Thank you so much for what I thought was a wide-ranging but very informative presentation.
Thank you.
Questions will be answered in a live session on October 18th, 2022 at 10:45 a.m. Central, 11:45 a.m. Eastern. Participate in the live Q&A with your Zoom invite details. These details can also be found in the Additional Resources tab on the left side of the screen.